In this video, we are going to revise a question from Mathematics Paper 2, 2022 GCE. Now, here we have question 8. In the diagram, XYZ equals 6 centimeters, angle YXZ equals 60 degrees, and angle XYZ equals 80 degrees. Calculate the length of YZ. Okay, so now we have been given a triangle here, and this triangle is a non-right angled triangle since it does not consist of a 90 degrees. And whenever you have a question where you are given a non-right angled triangle, sine rule and cosine rule must be used in order to find the distance, the missing distance, or the missing angle, depending on the need of the question. Now, our first step that we are going to do here, or revise, is you need to remember that an angle is denoted by a capital letter, while a distance opposite to that angle is denoted by a small letter. So what we are saying is this distance YZ opposite to our angle 60 degrees must be denoted by small letter x. Then for this distance YX opposite to angle Y must be denoted by small letter y. Then for YX, this distance of YX opposite to angle Z here must be denoted by small letter Z. Okay, now we can look at the numbers, the data that we have. We are able to see that we have two angles and one distance, and the question is we are trying to find the second distance. So if you have a problem where you have been given one distance and two angles, or maybe three angles, as long as you have been given one distance and asked to find the second distance, sine rule must be applied. So what we are saying is the distance that we are trying to solve is YZ. This is the distance that we are trying to solve. Now, our formula will begin with the x. X represents the distance that we are trying to find here, divided by its angle. So our angle will be x. So here on top, we have the distance that we are trying to solve, divided by the angle opposite to this distance, equals, now we need to be very careful here when choosing the other pair. We have to make sure that we choose a pair that has the angle and the distance. What I'm saying is we can't choose y, because the angle yes is given but the distance is missing. Now let's look at for distance for z. Distance for z is given, but the angle for z is missing. But since we have been given two angles here, we can find the third angle whenever you are dealing with a triangle. So what we are going to do is we can just say x. We'll just say, okay, let's not use x, but let's use z, angle z plus 8 degrees, then plus 60 degrees is equal to 180 degrees. Okay, then z plus, you add 80 plus 60, you are going to get 140. So we are going to get 140 degrees is equal to 180 degrees. So we can now collect the like terms. Our 140 will shift to the right side, and since on the left side it has a positive charge, and therefore the sign will change from positive to negative. So we have z is equal to 180 minus 140. Z is equal to 180 minus 140. We have 40 degrees. So what we are saying is the angle for Z is 40 degrees. Okay, so now since we have on this part the distance Z over its angle Z, so now this is the pair that is suitable in order for us to find the distance that we are solving for. Okay, so now we may proceed. We have x, the distance that we are solving, divided by the angle opposite to distance x. So we are going to have sine 60 is equal to, here on top we are going to have the distance z, 6 centimeters, divided by its opposite angle, which is sine 40 degrees. Okay, so since we are solving for x and we have two fractions on each side, I mean we have a fraction on each side, we are going to cross multiply. So our x will multiply with sine 40 degrees, our sine 60 degrees will multiply with 6 centimeters. So sine 40 degrees times x, we have sine 40 degrees x, then here we are going to have sine 60 degrees times the 6 centimeters. So we can divide by sine 40 also by sine 40. Then paper 2 calculators are allowed, so we can now calculate using calculator. So we can say sine 60 times 6 divided by sine 40. So our distance is 8.08 centimeters. So therefore we can say YZ is equal to 8 point, we can round it off to one decimal place, 8.1 centimeters. So this is our distance that is missing here, or we can just round it off to the whole number, so we can have 8 centimeters as our distance YZ. So this is the answer for part 1. Now we move on to part 2. Here we are trying to find the area of triangle XYZ. So now whenever we are dealing with a non-right angle triangle, and if we are asked to find the area, we are going to use the area rule under this topic of trigonometry. Okay, so now what we are going to do here is we are going to say area is equal to half AB sine C. Now this is the general formula. So what we are going to do is we need to replace the letters AB. So the letters AB represents the two distances that are making this angle here. So here we have three angles. We have 80 degrees, we have 40 degrees, we have 60 degrees. So we have to be careful of which angle are we going to use. So the angle that we are going to use here, we are going to use our 80 degrees, and the reason is simple. This is because the angle 80 degrees is formed by the two distances. So the two distances that you have will determine the angle that we are going to use. So what we are saying is we have these two distances. One is 6 centimeters, the other one is 8 centimeters. So the angle that is formed by the two distances is the angle that you are going to use under the area. So that is what we are saying. So AB must be those two distances. So one is x, the other one is z, times sine. Then our c is the angle, so our angle is y. So we can now proceed. We have half. Our x is 8 centimeters. Our z we have 6 centimeters. Sine 80. So we can first simplify. 2 can go into 8. So 2 into 8 we have 4 centimeters times 6 centimeters multiplied by sine 80 degrees. So we can go in the calculator. We have 4 centimeters multiplied by 6 times the sine 80. Okay, so we have an area of 23.6 centimeters squared. So that is the answer for Roman number 2. We move on to Roman number 3. We have calculate the shortest distance from x to yz. Okay, so we have from x to yz. So this is the distance that we are trying to find here. This is our shortest distance. So we can see this distance is coming from our point x, touching our distance x, is yz. So the formula for the shortest distance, we use that formula, the area for a right angle triangle. Now we can just say area is equal to half BH. Our h represents the shortest distance that we are solving for. Our b is the distance where the line is touching. So in our case, our b is distance yz, where there is 8 centimeters. Then for a, we have the area. We have calculated the area. Okay, so now we can now do the substitution. So area we calculated to be 23.6 centimeters squared. We have our b. We say the b is the distance where the line is touching. So the line from x is touching yz. So our distance is 8 centimeters. Then multiplied by our h. So we can see that we can reduce here. We can divide 2 into 8. We have 4 centimeters times h. So we divide by 4 centimeters here. We divide by 4 centimeters also. So we can cancel. We have our h is equal to, so we have 23.6 divided by 4. So we can see that the shortest distance is about 5.9 centimeter. So here, since here we are 1 centimeter, the centimeter from the denominator will cancel with 1 centimeter from the numerator, leaving us this centimeter that we have written here. So we've done this Roman number 3. We can move on to B. Solve the equation tan. So we've been given equation tan theta is equal to 2.75 here. Then we have also been given a range. We are solving. So here we are solving two angles between or from 0 up to 360 degrees. So now there is a memorable part that you can be used to remember the quadrants. We use as casti. So casti, the A represents all in the first quadrant are positive. Sine is positive, cos is positive, tan is positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. So we have tan positive. Then in the fourth quadrant, cos is positive. Now, the first quadrant here, the first quadrant runs from 0 degrees to 90 degrees. The second quadrant is from 90, so the angle between 90 degrees up to 180. Our third quadrant from 180 to 270. Then for 360, 270 up to 360. So these are what we call the quadrants, or they can also be denoted by the XY plane here. So we have our Y, our X. So this is our first quadrant, this is our second quadrant, this is our third quadrant, we have our fourth quadrant here. So now we can now go back to our question. So we can first look at the nature of our number here. We are able to see that our 2.7 is positive. So this simply means that we are finding two angles for tan where it is positive. So tan is positive in the first quadrant, tan is positive in the third quadrant. So we are finding two angles, one from the first quadrant, the second from the third quadrant. So we can begin. We can shift our tan to that side. So we are going to have a tan theta is equal to tan inverse of 2.75. So we can find so on the calculator you press shift, or depends with the calculator that you are using. If you are using a casual, you can press shift. Then if you are using a scientific calculator with second function, you can use a second function. So shift tan, then 2.75, we have our angle about 70.0. So we can just round it off to a whole number. So we can see that our first angle here is 70 degrees, and 70 degrees is found in the first quadrant. So we have found our angle, which is 70 degrees in the first quadrant. So what we are going to do is we need to find a reference angle, but this angle must be, we are going to get it in the third quadrant, since tan is positive in the third quadrant. So here, how to find the angle in the third quadrant? You add the angle from the first quadrant plus 180. So 180 plus 70, we have our 250, and we can see that 250 is in the range of 180 to 270. So these are the two solutions for question B. Now we can proceed with the last question. So we can proceed with the last question here. So this question we are told to simplify. Now first let's look at the problem here. We have the numerator where we have 1 minus 4x squared divided by 2 plus 2x. Okay, so what we are going to do is we are going to factorize the numerator, and if you can look at the numerator, we can make it a different of 2 squares. So what we are going to do is we are going to square 1, because we know that 1 times 1, we still get our 1. Now for 4 will be written as 2 squared, because 2 times 2, we still get our 4, x squared over 2 plus 2x. Then if you are solving a question where you are using different of 2 squares, you need to have 2 brackets here. So the first you have 2 ones, so one must be written here, the other one should be written here. So from in each bracket, the signs must change. Must be opposite. So one must have a positive, the other one must have a negative. And so it's like I made a mistake when copying. So this should be a 1. So one must be positive here, the other one must be a negative. Then we are going to have a 2. Then here 2, we have our x, also our x, then divided by 1 plus 2x. So we can see that from the numerator there is a pair that is exactly the same as our denominator. So this part where we have 1 plus 2x divided by 1 plus 2x. This part can be cancelled, giving us our final answer will be 1 minus 2x. So that's it for question 8. Subscribe and please share the video.